Draconian is the nickname of our next speaker. It's Robbe Van Roey, and we are very happy to have him here. He is working as a hacker manager at Integrity, a bug bounty platform. And besides that, he runs a YouTube channel with more than 11,000 followers, where he talks about anything security related. He also was invited to Radio Energy to talk about ethical hacking. And as social media shows, he maybe also likes to disassemble cars sometimes. Broken cars in a protected environment, but yeah, social media never forgets. So here we are, and please welcome Robbe Van Roey with bypassing CSPs Zero to Hero. Applause.
Okay. Hello, everybody, and welcome to my talk. So I already got a really great introduction. So yeah, this is me. Online, I'm Pink Draconian. I wasn't allowed to do a talk on why I'm named Pink Draconian, but I could talk about that for half an hour. So if you want to know, come later. I am a hacker, but according to the internet, I'm a stupid hacker. This is all in Dutch, but the top one says I'm stupid, that says I'm a loser, that says somebody wants to punch my face, and this one says that criminals are watching what I'm doing. So yeah, I'm a stupid hacker, but actually I'm an ethical hacker, because all those comments, they happened after I got in a local newspaper saying that I was a millionaire from one day because I hacked a Singapore company and stole $1 million from their bank accounts, which I did give back, sadly. But yeah. I'm an ethical hacker, and ethical hackers, they are, these days, there's a ton of them. And that kind of comes from the fact that companies want to be hacked these days. And this is something really exciting and really new. Ethical hackers, they want to hack, and companies, they want to be hacked. And I work for Integrity as a hacker manager, and we are a bug bounty platform. We connect companies that want to be hacked with ethical hackers. So how does that work? Well, a company can say, hey, we want these websites to be tested by everybody in the world, and we publish them on our website, and hackers like you can just sign up and start hacking on companies. Some examples here: Intel, they pay up to $100,000 for vulnerabilities, and obviously that's pretty difficult to find, so good luck. You have Red Bull, who pays out in Red Bulls, so if you want maybe an easier time, you can try to get some crates of Red Bull. But today I'm here to talk about bypassing CSPs, and the goal of this talk was to go from zero to hero. That zero I should already change, because we had a talk earlier that already covered CSPs, so you are all already quite knowledgeable on the topic. But why do I want to talk about bypassing CSPs? That's because nothing can stop the hackers. You can try to implement one, hackers are going to try to find a way to get past it, and in a lot of cases that will actually succeed. But in order to talk about CSP, we have to talk about XSS, cross-site scripting. You all know about XSS. XSS is extremely popular in bug bounty. People love it. Maybe it's because it's so easy to get started with. Just paste some alert payloads and see if something happens. Maybe that's the reason, or because it has such a cool name. But really quickly to summarize on XSS. So we have a source of XSS, a place where some user input, such as this get parameter name, is shown onto the screen without being sanitized. So the above example is bad for the developers, good for me. The bottom one is good for the developers, bad for me. Now, if you find such a source, you can use a payload such as here, an image, which has a source of X. That's going to throw an error, and I have an event handler there on error, which is going to throw an alert, which looks like that. Obviously, that is just a proof of concept of XSS. This doesn't show any impact of XSS, but there is, and this is a great proof of concept. But then CSPs exist. CSPs, content security policies. We've heard a lot about them already. Here are some examples of CSPs. So they pretty much talk about the security or where your content comes from. Where can it come from? In the top example, the content can only come from the own self origin. In the example below there, it can also come from example.com and start.example.com, and then you can get really advanced in this. And earlier, I think we looked at the Google one, which was really, really long. So yeah, you can just visit any website and get an example. But for a hacker, CSPs look different, because this is what they look like for a hacker. Here we see when an XSS tries to execute, but the content security policy blocks it. Above we see Firefox. Firefox is pretty nice, says the page's settings blocked it. Chrome takes a lot of pride into it and says, I refuse to execute this. But yeah, this is what hackers will see and what they don't like to see. Now, setting a CSP, again, we talked about it earlier. You can do that using a header. That's the preferred way. The bad, not really bad, but less preferred way is using a meta tag. And I'll show later why that is maybe less preferred. Yeah, this is a syntax. I can skip over that. These are all the directives you can use. I have put the ones that are actually interesting to us in bold. So the default source, script source, and base URI are interesting to this talk. So we'll focus on those. I think they're all fairly self-explanatory. Maybe the base URI, not really, but there's a base HTML tag, and that kind of defines what that can be. But I'll talk more on that when we talk about a bypass there. These are then the values that our CSP can take. None, I hate it as a hacker because it's pretty good, but you will probably not be able to have a website use none. Self, we talked about that. We have strict dynamic, which was talked about in a previous talk. Unsafe inline and unsafe eval, I love them. There's unsafe in the name, I love that. I'll skip over unsafe hashes, but host and scheme. So host is just host names that are allowed. So domain names, and scheme is HTTP or HTTPS. And then we have the probably preferred ones, which is nonce, and a SHA hash, so creating a hash of your script and including that. But that was the boring stuff. Let's get into some bypasses. I'm going to start really, really simple here and then build it up and try to see where we can get. So the first thing I need to do is create a little lab. This is my little lab. As you can see, I have a meta tag that has a CSP. Yes, I just said that meta tag was not really the best to use, but I did it because this is PHP and I am not a developer at all. Like, I am a hacker. I cannot write code for the life of me. So this was really impressive to me. But what I want to show you with this talk is kind of how a hacker thinks and how they might go about bypassing something. But here we clearly see our attack vector, the XSS here. There's just this name parameter, get parameter, that just gets reflected onto the page. Clearly an XSS. This is what our page looks like when my name is Pink Draconian. This is what this page looks like with the name of my future child. An image tag with an on error, like we showed earlier, and that causes an XSS. Okay, fairly simple. Now let's actually add a CSP to the mix. And this CSP is great. Unsafe inline, I mean, it's got unsafe in the name. What did we even expect? Of course, this is bypassable. In fact, well, let's first cover unsafe inline. Unsafe inline talks about inline scripts. So your script tag here is an inline script, and it also talks about event handlers. So if you add that into your CSP, then you are allowing these things to happen. What does that entail for our XSS? Well, our reflected XSS also is just an inline script tag, so that's allowed, and yeah, we have bypassed the CSP. Woohoo, our first CSP bypass. But let's go a little bit more secure, but still terrible. Star, because who thought the idea of allowing everything was good? Nobody. This is also super trivial to get past. So we see the example security content security policy here, and it allows scripts from hosts that match star, which is every single host, so with a payload like my attacker controlled domain /alert.js, we can get a really, really simple XSS. That was easy. I think everybody is still really can follow along. So let's make it a little bit more difficult. This time we are allowing content from a Cloudflare domain, a CDN.js domain, and we also have unsafe eval. Sometimes it's really nice to include JS libraries, JavaScript libraries from a CDN. I don't know if you all know what a CDN is, but it's pretty much a content delivery network. It's the idea of you have a server maybe somewhere in America. People here are contacting that and getting things back. But there are a lot of JavaScript libraries that almost every website uses. So if we bring that content closer to you, then you can go to the main website in America to capture the page. But then for the libraries, you can go somewhere in Europe to get it faster. That is the idea of it, and it's really nice. We also saw unsafe eval in our CSP. Unsafe eval allows the use of dynamic code evaluation, such as eval. I think, yeah, eval, we all know it's evil. So it has unsafe in the name still, so we don't expect much of this, right? Now, this is what our content security policy looks like. We're only allowing the loading of scripts from Cloudflare, and eval is allowed. So what does a bypass look like? Well, for that, let's have a look at the CDN. And here we have a listing of all the libraries that are in the CDN. As you can see, there's, I mean, a ton of really popular stuff. That's the whole point of it, right? Now, one of the libraries that is allowed is Angular.js. And that's, I mean, cool. A lot of websites use, or used, I should say, Angular.js. But there's also this version dropdown that allows us to select old versions, such as 1.6.0. And then the CDN is so nice to tell us that there's 9 vulnerabilities in this library. Okay, that sounds interesting. We are allowed to use this library, and it has 9 vulnerabilities in it. Could we potentially do something with this? Well, yes. So what we are looking for is to get an XSS. We cannot just get like a regular XSS, and with that I mean one that puts things, for example, allows us to load a script tag because we have unsafe inline is not there. So we have to look for something more specific. And Angular.js has this really nice thing called templates. An example is shown right there. You have our curly braces, and 1 + 1 becomes 2. That is amazing. So somehow that must be evaluating something, doing something. But sadly, if we just try to put an alert in there, that will not trigger because there is an Angular sandbox, which is a very limited instruction set of things that it's allowed to execute. And for example, access to the global object window.alert, that is not allowed. But sandboxes can be escaped, and there is a really, really great blog post from Portswigger by Gareth Hayes, who talks about DOM-based AngularJS sandbox escapes, and there's also a full list of them for different Angular versions, how you can bypass them. And that makes it really easy for us, because we can load in any version that we like. We just pick one of these here, and our payload will look like this. So first of all, we have a script tag with the source of our Cloudflare CDN of the vulnerable AngularJS library. And then we create an ng app and use our sandbox escape to execute an alert. And that is beautiful, and that works. Amazing. But obviously, this still uses unsafe eval, and it has unsafe in the name, so I mean, maybe not a lot of websites will do that. Is it possible to also get an XSS if we don't include that unsafe eval, if we literally just allow cdnjs.cloudflare.com? Well, let's find out. So this is what our policy will look like. First of all, does our previous payloads actually still work? No, it doesn't. We get this error, the error that a call to function is blocked. And yeah, this call to function is very similar to eval. It's blocked because unsafe eval is not present there anymore. Because AngularJS uses that somewhere in its entire call stack that you can see there. It needs to do that in order to execute our template. That is a bummer, so we cannot go that route. But people have found a way to do it, and this is the payload. This is a payload that is fairly well known to people who do it, but I was unable to find where it came from. I have no idea who created this, where this came from, and before creating this talk, or a couple of weeks back, I actually didn't even know why it worked. I just used it. And that is a very bad thing, because at that point, I'm just a script kiddie, right? I have no idea what is happening, but it works. Now, this is the same thing that a couple of challenge creators asked. Now, I'm a huge fan of CTFs, and at Integrity, every month, we host an XSS challenge, a website where you need to find an XSS, and if you do, then we give out 300 euros in swag total to people that find it. And these two amazingly talented people created the hardest challenge we've ever hosted yet. Only 4 people on the entire internet solved it. Over 1,000 people tried. So it was really, really difficult. And one part of it was a CSP bypass. We have done a ton of other XSS challenges in the past. This is a full list of them, and we keep on doing them monthly. So definitely check that out if you want to challenge yourself. But this is what the challenge looked like. We have a business card generator, and you can enter your name and enter some stuff on the business card, and then it generates it for you, and it was vulnerable to XSS. But the creators implemented a firewall, and this firewall blocks dangerous words, such as eval, set timeout, but also proto. Now, just by chance, this payload that everybody uses, but that nobody really knows why it works, uses the library prototype.js. What a bummer. We cannot use this payload anymore by pure chance of this WAF blocking it, so we need to do something else. And for that, we actually need to understand why this works. Now, first of all, we see here that in our ng app, some things have changed. We now have a call to on.curry.call. That is interesting. What if you were to run on.curry.call yourself in your browser, it would return window. So that already gives us an idea of what's going on, because then you would have window.alert XSS. But just running window.alert XSS doesn't work because of the sandbox. The fact that we can call on.curry also means that it gets added to the function prototype. Now, if you're not deep into JavaScript, maybe you haven't heard about prototypes. I will not go into it because that would be a huge rabbit hole. But yeah, those are two important things. Here we also see the source code of curry. So I just said that curry returns window, but looking at the source code, that is not really true, because really only the first line is important to us, which says that if there are no arguments, which is the case, then it returns this. So this somehow becomes window in that case. That is quite interesting. But if we look at the documentation for the call function, we see that the this_arg has a value to use as this when calling the function. And null and undefined will be replaced with the global object. Well, we are not supplying it, so it will be undefined, so it will become the global object, and that way we can get outside of the Angular sandbox, and that works. But okay, now that we understand it, we need to modify it, because we cannot use this prototype library, and curry is from the prototype library. So we need to find a library that has these two things in common. It gets added to a prototype, and it returns this. And that was done. And among all the 4,290 libraries in that CDN that we talked about, only 74 libraries pollute a prototype. And of those 74 libraries, 12 of them have functions that return this. So there's actually 12 possible libraries to do this. One of them is mootools. No idea what it does. No idea why it's there. If anybody does, educate me. But yeah, that pollutes the array with an empty function. And if we use that, we can get an alert to work. I didn't do most of this research that was done by this top guy, who is really, really amazing. Definitely read his blog post. And there's also a tool to fully automate the process of finding those libraries created by Swappy. But yeah, that's that shows to me why I love CSP bypasses so much, because there is so much creativity involved in doing things. And every time it's totally different, and you get to go into these crazy, crazy rabbit holes that is so much fun. But okay, what have we learned? We learned CDNs, maybe don't allow them. But, I mean, allowing something like just Google.com, that should be safe, right? Google is the biggest, they're all about security. This is definitely secure. No. Yeah, don't do that either. And here we see an alert. Our alert also has some really interesting text there. We see an hello, hello fresh, hello bank, hello kitty, hello magazine, hello goodbye and everything, hello in Dutch, which is hallo. What is going on here? Well, in order to understand this, we need to talk about JSONP. JSONP is a historical JavaScript technique. And I love that sentence. Historical technique, like as a hacker, oh, that really gets my juices flowing. So what does it do? Well, it's a technique for requesting data by loading a script element, and it enables the sharing of data bypassing the same origin policy. Like a JavaScript technique that bypasses a policy? That sounds pretty good to me. So how does that look like for Google? For this CSP, we can have this bypass. So we're including the script of google.com/complete/search, which completes your search. So if you type something, it will give you the results, the autocomplete results that it suggests to you. We're the client Chrome. The question is, or the query is hello. So that might ring some bells with what we saw earlier. And then there's this amazing, amazing other parameter, callback. So what does that mean? Well, after it gets the data from this Google API, it runs the callback on our page. We are allowed to include this because google.com is allowed. So yeah, that is what causes this to work. Even when self is in a CSP, it works, and we get this output. We alert the results of, or the autocomplete results of hello for my Google account, which apparently is Hello Kitty. Yes, don't ask questions. And this is all really cool stuff that is based on these host whitelists. So you have big issues with CDNs, with pages that have JSONP. But there's also sometimes some crazy things that are possible when you use some amazing programming languages, such as PHP. Who here in the audience actually uses PHP? Oh God, good luck. No, this is a really specific case that I just want to detail because it's really interesting, but this is a PHP response buffer overload, which is cool. It also comes from an XSS challenge that we made, created by Bruno Modificato. And in this challenge, we can send a message in plain text and a hashing algorithm, and it will hash it, and that's cool. So if we send something, we get this page. Amazing. So what happens if we try to send an image tag as our plain text? Well, this page is vulnerable to XSS, so that will work, kind of, because, well, we get our error message that the CSP is blocking this. Bummer. But what if I do this? My payload remains exactly the same, but as the hashing algorithm, I just have a ton of A's. That works. And this is really cool and so random. It has nothing to do with CSP, really, but this bypasses the CSP. And we see some interesting stuff in the background. We see an error, or a warning, rather, that the hashing algorithm is not allowed. And then this bottom warning is maybe even more important. It says, cannot modify header information. The headers are already sent. So that should maybe give us some intel as to what is going. Because in PHP, order really matters. We can't send the body before sending all of the headers, because then we're going to get in trouble. You expect all the headers and then the body. But what if there are warnings first? What if in your code there is something that happens and that produces a warning? That warning already gets produced, and then later you're setting your headers. Well, that causes some issues because PHP buffers responses until there are 4,096 bytes. So if we have warnings that produce over that amount of bytes, well, that first response buffer gets full and gets sent. And now at this point, you're trying to still add a header to that, but PHP is like, oh no, I can't do that. I already sent some data. And that is how you can bypass a CSP in really extremely specific cases. But it's still something that makes you think, PHP, I love you. So yes. So then why do I love bypassing CSPs? It's because of this creativity. I talked about it earlier. And that was actually going to be my talk, but then there was this previous talk that covered a bunch of stuff that I was planning to talk about. So I spent my time here to add some extra stuff to it. Yay! For example, what if you miss your base URI? Let's take this code here. We see that we have a CSP, which has a script source with a nonce. Nonces are great, right? Amazing. This must be super secure. We have our script that has this nonce, and that loads JavaScript app.js. Let's say somewhere in this code there is an XSS, or an HTML injection. We're allowed to inject HTML. What happens if we inject this, the base HTML tag? Now our code that the browser receives will look like this. And the base tag is pretty much going to be the base for all relative URLs. So at the bottom here, we have a relative URL, /js/app.js. So now the browser is going to get that at attacker.com/js/app.js. And as you can see, it tries that from attacker.com, it gets it, and that results in this beautiful thing that I love to see. So what is the lesson there? Base URI should always be something that you also have in your CSP, because else this will happen. And the funny thing is, I was earlier talking to somebody after that first talk, and they said, oh, I implemented a CSP after that talk, it's so amazing. And I looked at it, and well, it was vulnerable to this. So yeah, it apparently actually happens in the real world. That's cool. Now, one final example before I'll end this talk, and this is a bit of a quiz time. On Twitter, we sometimes post things like this. We have a code sample, and it is vulnerable, and we need to spot the vulnerability, and I'll actually give away a €25 voucher to some really cool t-shirts that I'm not even wearing myself, but they're really cool. There's also stickers, hats, all that stuff. So for the first person that can find the vulnerability here, how can I bypass this CSP? Who knows? Sorry? That is pretty interesting. I don't think that will work, but that's a great thinking. You can try it. Anybody else? Well, this is going to be a cheap talk for me. No thing to give away. So yeah. This is the payload that will actually make things work. First of all, we go out of the title. We need to do that because the title tag only allows text, so we escape out of the title, and then we just add our script with an alert. And that works because the browser will only enforce the CSP after it has seen it. But in this case, well, our payload would be before the CSP gets set, so it doesn't really matter anymore at all. And this is one of the reasons why I use the headers, because headers always get parsed before the content is loaded. So yeah, just a fun example of something that will probably never really happen in real life, but that is fun. And that was my talk. I have some more links here. So a link to all the XSS challenges. If you want to challenge yourself and give it a go, follow Integrity on Twitter, follow me on Twitter. If you think right now, hey, I want to get hacking and actually earn some money while legally hacking, or if you work for a company and think, hey, we could maybe use bug bounty, visit the website, check us out on YouTube. Integrity and Pink Draconian also make a lot of cool content there. But that was my talk. I hope you enjoyed it.
So thanks a lot, Robbie. That was really great and interesting. And we have some questions already. The first question is, can I disable JSON-P with a CSP?
Disable it.
Disable, yes.
Don't add it to your CSP would be the right thing to do here. Disable it, not really. If you include a domain that has JSON-P, then yeah.
Then another question. Which of the presented browser's features is an absolute must-use?
Sorry?
Which of the presented browser features is an absolute must-use?
Could the person that asked that detail what kind of features he...
Browser features you presented?
Did you present browser features? Did we saw the same presentation?
Okay, so this person can maybe ask the question afterwards
Definitely,
again.
definitely.
Okay. Modern Angular versions do not have a sandbox anymore. Does this mean that its security has gotten worse?
No, I believe. I'm not that big into the security of the current Angular and how all of that works. But I haven't seen these bypasses for there, so I don't think, it definitely hasn't gotten worse. Yeah.
Who creates those amazing drawings in your slides?
Okay, yeah, that's a really good question, actually. Let's go back to one. So this one, for example, this is an actual hacker on Integrity. This is a hacker, I've forgotten his name, but we have a leaderboard, and if you're a hacker and you get to the top 3 in the leaderboard every quarter, you get one of these amazing portraits. It's like a real must-have for these hackers. They all battle to the top 3 to get this because it's super cool. So if you want your own portrait, then get hacking and get to the top 3, I would say.
Okay, and we have one last question here. I hope I get... What? Do you know of orgs, O-R-G-S, orgs, actually defining a CSP via the meta element, or was this just for the presentation?
This was mainly just for the presentation. It happens in some cases with developers that maybe aren't that educated, and it's not always a very big issue. But yeah, I mainly hunt on smaller companies, and there you can see some crazy stuff. But the thing that I see the most is companies that don't have a CSP at all. Yeah, let's maybe first get everybody to use a CSP, and then we can really improve the security, because so far it's terrible. 90% of companies just don't have a CSP at all.
Okay, thanks a lot.
Thank you.
And as we have a few minutes left, because you said pink dragon, so maybe you can pink draconian. Oh my God, I'm so sorry. So maybe you can just say just a few words why this name, because you said you would need a lot of time, but maybe.
Okay, so yeah. I think pink is a really happy color. It's really fun. But draconian is an adjective in English. I don't know how many of you know the adjective, but it means if something is draconian, it's very severe. Like laws can be very severe, and it stems from a Greek emperor, Draco, and he was the first to really implement laws, and his laws were insane. Like if you would cheat on your wife, you would be killed, stuff like that, or lit on fire for stealing something really small. Which I just find amazing. Those are really great laws, in my opinion. No, and like the dark history there kind of contradicts with the happy color, and that makes me a happy person. And that's why I chose my name when I was still a gamer and not even into security. But now I still carry that with me. Yeah.
Cool. So thank you again.